So yesterday we finished up to here. We finished the capacitors in series and parallel. So today we are going to discuss the cylindrical capacitor. My dear, the most important thing, we need this formula. So the explanation of this formula is given here. So here, if you want to derive the formula for the cylindrical capacitor or cylindrical conductor, what you have to do, first you have to find the potential. So how to find the potential? If you want to know this, because this slide has two parts, part number one, and this is your part number two. Am I right? So if you want to get the part number two, first of all, we must know how the potential will get from the cylindrical conductor. So we have to go back again to chapter number 23. Because in chapter number 23, we studied the concept of infinite line of charge. Am I right?
Yes.
Infinite line of charge. We already studied this. What is the formula for infinite line of charge? We already know this formula, electrical field for the line of charge, which is equal to lambda divided by 2 pi epsilon naught multiplied by R. And also, if you just see these type of conductor, my dear, it has two radius. One is inner wire and another one is outer layer. So inner layer and outer layer. The inner layer has the radius of R1 and the outer layer has the radius of R2. And if you just see here, we can store the charges positive here, we can store negative charges here. So it's exactly same like infinite line of charge. That's what we are going to choose this formula. So the most important thing, we are going to find our voltage, that means the potential between these two layers. So what we have to do, we have to use the relation connecting electrical field and the potential. In chapter number 24, we studied this relation. Am I right? Am I right or not? We studied this relation. So I am going to use this relation. If you just take this dV this side, when you move the e to the right hand side of the denominator, your equation becomes dV, which is equal to E multiplied by dr. That's what we got this relation here. Now this is for only for small portion of the potential. So if I want to get the entire potential of this cylindrical conductor, I have to integrate. So what I have to integrate? I have to integrate from the outer layer to the inner layer. So what I am going to do, if I want to find the information for the entire line, entire cylindrical conductor, I have to integrate this. So I am going to substitute the value of a EDR here, because once you substitute the value here, you will get this information. Now what I am going to do, because this is exactly like a line of charge, so I am going to take this E, I am going to substitute here. If you take the E value, when you substitute here, your equation will be like this. So I am going to move all the constant term outside. What are the constant terms you have? Negative, I take it outside. Lambda is a constant. 2 pi epsilon naught is a constant. So I take all the constant outside. But what I am going to integrate? I am going to integrate only 1 over R multiplied by dr. And my limit extend from R2 to R1, because my R2 is the outer layer and R1 is the inner layer radius. So when you integrate this 1 over R multiplied by dr, you will get natural log of R. So when you substitute the limit here, what will happen? Negative of lambda divided by 2 pi epsilon naught. When you apply the upper limit, what is our upper limit here? Our upper limit is R1. So when you apply here, this equation becomes natural log of R1 minus natural log of R2. Now what I did here, I just multiply this negative inside. When you just multiply this negative inside, what will happen? Your R1, natural log of R1 gets negative, my natural log of R2 get positive. That's what I rearrange this equation like that. So when you just see the final answer, this is the potential across these two layers. So now what I am going to do, I am going to take the capacitance of the capacitor, because we know this information. My capacitance of the capacitor C, which is equal to Q over V. And also here we have lambda. What is lambda, my dear? In chapter number 23, we studied lambda. What is lambda? It's a linear charge density, which is equal to Q over L. So I am going to substitute this value. So my Q is here. Therefore, my Q, which is equal to lambda multiplied by L. So I am going to take this. I am going to substitute here. and I'm going to take this V, I'm going to substitute here. So when you substitute these both, what will happen? This lambda and this lambda get cancelled, and this 2 pi epsilon naught will come to the numerator of this equation. So finally your equation will be like this. Am I right? Am I right or not? So the final equation of this cylindrical conductor, the capacitance of the cylindrical conductor, which is equal to 2 pi epsilon naught L divided by natural log of outer layer radius divided by inner layer radius. Clear, my dear? But in the exam, we are going to use only the equation, the final equation. So we have one problem based on this equation. Clear, my dear? Clear?
Clear, doctor.
Okay. Now we are going to conclude this. What, my dear?
We use the final rule to find the
Yes,
capacitor.
we are going to use only the final rule. Capacitance C, which is equal to 2 pi epsilon naught L divided by natural log of R2 over R1. We are going to use. These are all the explanation how we got this equation. Clear?
Clear, doctor.
Okay. Now we come for the final, which is nothing but dielectric. I told you in the last class, dielectric is an insulating material. So what is our insulating material? Paper, plastic, glass, rubber, and these are all the insulating materials. So when you kept insulating material in between the capacitor, what will happen, my dear? So your capacitor will separate with some distance d. When you put any insulating materials in between the capacitor, what will happen? What will happen? It will increase the efficiency of the charge storage. Am I right? Yesterday we saw this information. When you put any insulating material, which is nothing but the dielectric, when you put any dielectric material in between the plates, what will happen? It will increase the efficiency of the storage of the charge. So what we are going to do, we are just going to use the same equation. What is the equation of the parallel plate capacitor? My parallel plate capacitor is A multiplied by epsilon naught divided by D. We studied this equation yesterday. Am I right? Am I right or not?
Yes.
So if your question is related with dielectric, just do only one thing. Write the same equation, but please multiply with K, because here K represented the dielectric constant value. So if you want to write the equation in terms of dielectric, what I'm going to do, I'm going to write the same thing, A multiplied by epsilon naught over D, but I have to multiply with a letter K. What is K? Here K is the dielectric constant. So my dear, listen carefully. This K doesn't have any unit, because dielectric constant is just a number. So if you take a wax, it has some value. If you take a paper, it has some value. If you take a glass material, it has some value. So whenever you substitute the value, whenever you introduce some dielectric material in between the capacitor, what will happen? Your capacitance value get increased. Clear, my dear? Clear? So please, while you solve the problem, suppose if the question is related with the dielectric, read each and everything clearly. Then only your answer will be correct. Otherwise, totally wrong. Because if you forget to substitute the value of K here, what will happen? Your total answer will be different. Clear, my dear? Understand?
Yes.
Okay, that's it. So these are all the problems we are going to discuss now. Could you please recall the formula? Today we studied many formulas, am I right? Especially in this chapter, we studied many formulas. So I'm going to explain, I'm going to first recall the formula, and then we will go back for the numerical question. Clear, my dear? Understand?
Yes.
Okay. Could you please tell me what is the formula for capacitance of the capacitor? What is the formula for capacitance of the capacitor?
Q over V.
What happened to the pen? Okay. What is the formula for capacitance of the capacitor? C, which is equal to Q over V. Am I right? What is the formula for parallel plate capacitor? Capacitance of the parallel plate capacitor? C, which is equal to A multiplied by epsilon naught divided by D. Am I right? Am I right or not?
Yes.
What is the formula for energy storage? You have two formulas for the energy storage. U, which is equal to C V square over 2, and also you have another energy formula which is equal to Q square over 2C. And then we studied the formula for energy density. So energy density, you have two formulas. What are they? Charge per unit volume or your energy density, which is equal to electric field square multiplied by epsilon naught divided by 2. So this is the rule for energy density. And then you have capacitance in parallel and series. If the capacitance is in parallel, what will be the rule? My equivalent capacitance, which is equal to C1 plus C2 plus C3 plus up to n number of capacitor. How many capacitor you are going to take? We have to use this. Suppose if the capacitance in series, what you have to do? 1 over C equivalent, which is equal to 1 over C1 plus 1 over C2 plus 1 over C3 and so on. So these are all the formulas today we are going to use. And also one more formula. What is the formula for potential? The potential, which is equal to electrical field multiplied by distance. For example, if you take a capacitor, one plate will store positive, one plate will store negative. So what will happen? You will get the electrical field. Am I right? Am I right or not? So if you want to find what is the potential between these two plates, you have to write my potential between the two plates is nothing but electrical field multiplied by the distance between the two plates. So I have to write ED. So this is one of the important formula, and we have one problems related with this rule. So these are all the formulas we are going to use in this chapter. And also one more formula is left. What is that? Cylindrical capacitor. What is that, my dear? C, which is equal to, just before we saw, 2 pi epsilon naught L divided by natural log of R2 over R1. Am I right? Is any other formula is left? Dielectric. Suppose if you have a dielectric material, what will happen? K multiplied by A epsilon naught divided by D. So these are all the rules we studied from this chapter. Clear? Understand?
Yes.
Okay, now we are going to solve this question. My dear, listen carefully. This question has 5 parts. This question have 5 parts. So read the question very carefully. The parallel plate air filled capacitor. What is the meaning for air filled, my dear? For example, capacitor will be like this. Am I right? Your capacitor should be like this. Am I right? It should be separate with some distance d. Am I right? Am I right or not?
Yes.
So
Yes, Doctor.
in between the plate, what you have? Only air is there. Am I right? So that's what they written here. Parallel plate air filled capacitor. Air filled capacitor means there is nothing in between the plates. Only the gap should be there. So in that gap only air will be there. That's what they mentioned here. A parallel plate air filled capacitor having 40 centimeter and plate spacing 1 millimeter. That means the area of the plate is given. What is the formula for area? So here the area of the area value is given, which is nothing but 40 centimeter square. So if you want to convert the centimeter square to meter square, what you will get, my dear? 40 multiplied by 10 to the power of minus 4 meter square. Why? Because 1 centimeter, which is equal to 10 to the power of minus 2 meter. Therefore 1 centimeter square, which is equal to, just squaring all this, what will happen? This becomes 10 to the power of minus 2 the whole square meter square. So finally you will get 10 to the power of minus 4 meter square. That's what we written here as 40 multiplied by 10 to the power of minus 4 meter square. Now, okay, what else is given? Space is given, d value is given. So that the distance between the two plates is given, which is nothing but 1 millimeter. That means in terms of meter, 1 multiplied by 10 to the power of minus 3 meter. And what is the potential between these two plates? That means the voltage across these two plates is given. What is that value? 500 volt. That means the voltage between the two plates, which is nothing but 500 volt. Now, by using this area, by using this d value, that means the space between the plates, and by using the potential between the two plates, what are the things we are going to find? We are going to find something. What are the things? First one, we are going to find the capacitance. So this is our first question. And second question, what we are going to find? We are going to find what should be the charge sitting in the plates. And third one, energy stored. That means we are going to find the capital U. And then fourth one, we are going to find the electrical field. And then fifth question, we are going to find the charge density, small u. So these are all the 5 answers we are going to get from this question with the help of these parameters. What are the parameters? Area, d and v. That means distance between the two plates and the potential. Now, my dear, first I am going to solve the A question. What is given in the A question? We have to find the capacitance. What is the formula for parallel plate capacitor? Because they clearly mentioned this is
A
the
epsilon
air filled capacitor. That means the capacitance with the parallel plate capacitor. So what's the formula?
for D.
What's the formula for the capacitance of the parallel plate capacitor? C, which is equal to A multiplied by epsilon naught divided by D. Am I right?
Yes.
So now you can see area is given. What is that value? 40 multiplied by 10 to the power of minus 4, and epsilon naught is the constant value which will be given. So don't worry. 8.85 multiplied by 10 to the power of minus 12 divided by what is the distance between the plate? 1 millimeter, which is nothing but 1/10 to the power of minus 3. When you just use your calculator, you will get the answer for the capacitance. Am I right? Am I right or not?
Yes.
What is the unit for the capacitance? What is the units for the capacitance, my dear? The unit for the capacitance is farad. Clear? Understand?
Yes.
Okay. What is your second question? What is your second question?
Charge.
My dear, could you please tell me the answer? Could you please tell me the answer of this? Better we can check the answer.
It's 54 multiplied 10 to the power of minus 11.
So 3.54, 10 to the power of minus 11. Huh?
Yes.
My dear, I don't have, my dear, listen carefully. I need your answer because I don't have the calculator right now because it's in my office now. I forgot to leave, put my my calculator there. So please check the answer carefully because I need the answer from your side. Don't see the answer from the slides. Please work out the answer by yourself and please let me know the correct answer. Understand?
Okay.
Yes, doctor.
Okay. What is your second question? We are going to find the charge. So if you want to find the charge, we know the capacitance of the capacitor. What is the rule for capacitance of the capacitor? C, which is equal to Q over V. Am I right? Am I right or not?
Yes.
Therefore, Q, which is equal to?
CV.
Okay, now
CV.
C, you already have. Substitute the C value. What is your V? V is already given in the
500.
question. So Q, which is
500.
equal to 3.54 multiplied by 10 to the power of 11 multiplied by my voltage is 500. So what should be the answer, my dear? Tell me the correct answer.
1.78.
1.78
multiplied by
multiplied
5
by
minus 8.
minus 8 coulomb. So this will be the answer
8.
for the second question. Clear? Clear, my dear?
It's clear.
Okay, what is our third? We have to find the energy stored. So we have two formulas. What are the two formulas we have for the energy? We have two formula, U which is equal to CV square over 2 and also U which is equal to Q square over 2C. Am I right? Choose any one of the formula. Your answer will be the same. Understand? It's up to you. If you want to choose this one, no problem. Or if you want to choose this one, no problem. Your answer will be the same. So for the time being, first I will calculate and then we will check this. Okay. So first I am going to substitute the value of C because C, the first question we already found. What is the value? 3.54 multiplied by 10 to the power of minus 11 and our voltage is 500 and it should be squared divided by 2. Could you please tell me the answer?
4.42
4.42 multiplied
multiplied
by
by 2 minus 6.
minus 6. What's the unit? It should be joule. Okay, let's we check this answer. Okay, what is the value of Q? Q is here. Substitute the value 1.78 multiplied by 10 to the power of minus 8 square whole square divided by 2 multiplied by 3.54 multiplied by 10 to the power of minus 11. Could you please tell me the answer? For sure your answer must be the same. It will not different answer. For sure both will be the same. What is your answer?
I get 4.47.
Both are correct. 4.42 or 4.47. What's the difference? Power is same, am I right?
Yes.
So both will be the same approximately. My dear, this is the third digit. After the decimal, we got second digit. Second digit, it doesn't matter. But the first two digit and the power of the 10 will be very, very important. Clear? Understand?
Yes, doctor.
Okay. What is our fourth question? We have to find the electrical field and then we have to find the energy storage. That means the energy density. So in the D question, we are going to find the electric field. My dear, if you want to find the electrical field, we know the rule potential which is equal to electrical field multiplied by distance. Am I right? Therefore, my electrical field which is equal to V over D. So V, it's already given in the question and D is also given in the question, which is nothing but 1 millimeter. So I converted to meter. What should be the answer? This 10 to the power will go to the top and already two zeros will be in the numerator. So for sure the answer will be 5 into 10 to the power of plus 5. Am I right?
Plus
Am I right
Yes.
or not? So
5
unit will
or
be,
3, doctor.
my dear, denominator you have minus 3. If this 10 to the power of minus 3 will go to the top, this becomes 10 to the power of plus 3. Am I right? That means already
Yes.
two more zero is there. So 5 multiplied by 10 to the power of plus 5.
Yes, yes.
Clear? Understand?
Clear. Yes.
And then our last question, we have to find charge density, small u. My dear, you have two formulas. What are the two formulas? U divided by V, or you can write U divided by area multiplied by its distance. Am I right? Because volume, you can write like this. Am I right? And also you have another rule, U which is equal to E square epsilon naught over 2. So if you use this or this, you will get the same answer. Let's we check. Okay. So first I'm going to use this equation. My U which is equal to, what is the energy density? Because energy stored we already find. What is the value? 4.42. Am I right? Am I right or not?
Yes.
4.42 we got. So I'm going to use this value 4.42 multiplied by 10 to the power of minus 6. My area is given. What is the value of area? It is 40 centimeters square, which is nothing but 10 to the power of minus 4. And my distance is 1 millimeter, which is nothing but 1 10 to the power of minus 3. Could you please tell me the answer? Could you please tell me the answer?
1.105.
1.105. Is there any power?
No.
Okay, what's the unit? Because you can see the unit for the charge, the unit for the energy is joules and the unit for the area is meter square, and here you have another meter. That means what's the unit? Joules per meter cube. Clear? Okay, let's
Yes.
we try it with this formula. What is this? Electrical field just before we find. What is the value? 5 multiplied by 10 to the power of 5, the whole square, and the epsilon naught value is the constant 8.85 multiplied by 10 to the power of minus 12 divided by 2. Could you please tell me the answer? This is small u, not capital U. This is small u. Okay. What's the answer?
Uh, 1.106.
See, the answer exactly the same. Am I right?
The same.
Yes.
Yes.
So either you can use this or this. No issue. It's up to you. Which one will be the comfortable for you? You can use this. So you can see the question. 5 parts we have in this question, but we must strong in the formula. My dear, if you don't know the formula, it's really very hard. So please read the question and please memorize the formulas. Otherwise, you cannot be able to solve. Understand? Clear?
Clear, doctor.
Okay, let's we go to the 12th question.
Doctor,
Yes, my dear.
I have a question.
Yes, brother. Ask your question, Hassan.
According to the first and second part, for the capacity, it depends on the factors which we have, because we have two laws, right?
Two?
The first and second part of the question,
Okay.
to find the capacity.
Capacitance, not capacity, capacitance.
Oh, sorry.
Okay.
We have two laws, so we apply the laws depends on the factor, because in the first part we
Yes,
have
my dear, listen carefully. In the question, read the first line. They clearly mention this is the parallel plate capacitor. Am I right? Am I right
yes,
or not? This is the
yes,
parallel plate capacitor. So for sure you have to use this, because if you want to use this, where you will go for the charge? Is it possible to get the charge? Is there any information about the charges here?
No.
So how you will use the second one now?
Oh, okay.
Clear? So read each and every word. Each and every word is very, very important for solving the problem. Okay. According to this question, from the first line itself, they clearly mentioned this is the parallel plate capacitor. We have the rule for parallel plate capacitor. So I can directly write the rule.
Okay.
Clear?
Yes.
Okay. Now, let's come for this one. What is given here? An air-filled parallel plate capacitor has the capacitance value for 2.1 picofarad. So they clearly mentioned the capacitance value. That means what type of capacitor you have, my dear? My dear, please listen carefully. You have the capacitor, and this capacitor has the capacitance value. What is that value? What is the value, my dear? What happened to you? 2.5, sorry, 2.1 picofarad. What is the meaning for pico? 10 to the power of minus 12. And then you separate the plates. That means the separation of the plate is double. So that means you increase the distance double the time of the first one. And then you introduce one material in between. So that means the second diagram, so your capacitor plates get doubled, and you insert one material which is nothing but a wax material. Am I right? Am I right or not?
Yes.
Initially you have the d distance, and what is the distance here?
More
2D.
2d, because they clearly mentioned doubled. That means the distance gets doubled. Now after you put this wax in between, what is your capacitance value? My capacitance value is 2.6 picofarad. See, when you put any dielectric material in between the plates, the capacitance value will be get increased. We studied just before. Am I right? But you can see the value here. Before you put the wax, my value is 2.1 picofarad. But after you put the wax, what is my value? It is increased. So whenever you insert any dielectric material in between the plates, you will get higher value. So by using this concept, what we are going to find? We are going to find the dielectric constant of the wax. That means we are going to find the value of the K wax. That means you put some wax material. So the wax dielectric value is a constant. So we are going to find the value of K. Clear? Understand, my dear?
Yes, doctor.
Okay, now we have the formula for the parallel plate capacitor. So I am going to apply that formula for two cases. This is my case 1. This is my case 2. Am I right? In case 1, it is empty. That means nothing is in between the plate. So we have the formula. What is the formula, my dear? C, which is equal to A multiplied by epsilon naught divided by D. Am I right? Am I right?
Yes.
Okay, for this case, you put some dielectric material. So how you will write the formula? C, which is equal to K multiplied by A epsilon naught. What is your distance?
2D.
2D.
So you have to write. So what I am going to do, I am going to take, this is my first equation. I am going to take, this is my second equation. So this is with the air-filled capacitor. This is wax capacitor. Am I right? Am I right or not?
Yes.
Okay, now what I am going to do, we are going to find the value of K. So I am going to divide the second equation by first equation. So I am going to divide second equation by first equation. So first I am going to find, okay, because we have the value for air-filled capacitor. What's the value, my dear? This is 2.1 picofarad. And what is this value? 2.6 picofarad. Am I right? Am I right or not?
Yes.
Yes.
Okay, I am going to divide the second by first. So this is my capacitance value of the second one. This is the capacitance value of the first one. So I am going to divide the left hand side. So what I will get? 2.6 multiplied by 10 to the power of minus 12 divided by 2.1 multiplied by 10 to the power of minus 12, which is equal to this value divided by this value. So what you will get, my dear? K A epsilon naught over 2D divided by this value, A epsilon naught over D. So when you expand this equation, what you will get, my dear? So better I can just delete this one, because you can cancel this 10 to the power of minus 12. So here you will get 2.6 over 2.1, which is equal to, how I can write this? I can write Ka epsilon naught over 2D multiplied by D divided by A epsilon naught. Am I right? Am I right or not?
Yes.
So I can cancel this D and this D. I can cancel this A epsilon naught, A epsilon naught. What is remaining? 2.6 over 2.1, which is equal to K over 2. Am I right?
Yes.
So we are going to find the value of K. Therefore, my K, which is equal to 2 multiplied by 2.6 divided by 2.1. Am I right? Am I right?
Yes.
Could you please tell me the answer? So this K is the value of the dielectric for the wax. So what should be the answer? Tell me the answer correctly.
Uh, 2.47.
2.47, my dear, this is unitless. So the value of the K is unitless, so no unit. So my dielectric constant for the wax is 2.47. Clear, my dear? Understand? Clear?
Yes, doctor.
Any
Yes.
doubt? Any doubt?
Clear.
Okay, that's great. Okay, let's we go for the third question. Let's we go for the third question. So I can cut, I can put it here. Okay, read the question very carefully. What is given here? A coaxial cable used in the transmission line has an inner radius of 0.1 millimeter and an outer radius of 0.4 millimeter. My dear, generally in our household items, sometimes when you cut the wire, you will find wire inside a wire. Am I right? Am I right or not?
Yes, you're
Yes.
right.
Especially some transmission line wire, if you cut, you can find another wire will be inside. Am I right? So your wire should
Yes,
be
you're
like this.
right.
You can see the picture. You can see the picture. One wire and then another wire should be inside. Am I right? So we have the
Yes.
wire, and which is exactly the cylindrical in shape. So now what is given here? The wire inner radius is given. So I am going to take inner radius as R1. What is my outer radius? My outer radius is R2. So in between, you are going to keep something. So if it is dielectric, you have to put in between, because each layer you have some charge. Let me read the remaining part. Calculate the capacitance per meter for the cable. Assume that the space between the conductors is filled with epoxy resin with dielectric constant 3.5, 3.6. My dear, listen carefully. You have two layers. One is inner wire, another one is outer layer. So what they clearly mention, in between the two wires, you filled with some dielectric material. What type of dielectric material? They clearly mention. What is the value? The value of this epoxy resin is given. That means K value is given. What is the value of K? 3.6.
3.6.
So this question is related with again dielectric. So when you put the dielectric between the two wires, what will happen? It will increase the efficiency. Am I right? Am I right or not? And then this question is related with the cylindrical conductor. Just before we studied the rule, what is the rule for the cylindrical conductor? C, which is equal to 2 pi multiplied by epsilon naught multiplied by L divided by natural log of R2 over R1. Just before we studied. Am I right? Am I right or not?
Yes, doctor.
Yes.
But read the question very carefully. What they need? Capacitance per meter. They are not asking only the capacitance. They need capacitance per meter. That means capacitance divided by meter. So, my dear, what is the unit for length? What is the unit for length?
Meter.
Meter.
Millimeter.
So, I have to bring this L to the left hand side of the denominator. Am I right? So, when you bring, this is exactly becomes capacitance per meter. Am I right? Am I right or
Yes.
not?
Yes.
So,
Yes.
and also, my dear, the most important thing, you put some dielectric material. What I told you, whenever the question is related with the dielectric material, I told you to put the value of K here. Am I right?
Yes.
Yes.
So now I move this L value here. So this is exactly becomes capacitance per meter. That means capacitance over length is nothing but capacitance over meter. So now what are the remaining terms we have? K 2 pi epsilon naught over natural log of R2 over R1. Now, my dear, what is your outer radius? They clearly mention in the value. My inner radius R1 is given. What is the value? 0.1 millimeter. So I have to convert it to meter. And then my outer radius is given. What is the value? 0.4 millimeter. So I have to convert it to meter. Now the only thing we have to substitute the value. So C over L, which is equal to K value. What is the value of K?
3.6.
3.6 multiplied by 2 pi. 2 multiplied by 3.1 multiplied by epsilon naught is the constant. 8.85 multiplied by 10 to the power of minus 12 divided by natural log of my R2 value is 0.4 multiplied by 10 to the power of minus 3 divided by my R1 value is 0.1 10 to the power of minus 3. Clear? Clear, my dear?
Clear, Doctor.
Understand?
Yes.
Okay, tell me the answer. Tell me the answer, my dear. What is the answer? When you just work out with your calculator, what answer you got?
Uh, 1.44.
1.44
Multiplied by 10.
multiplied by
10
power
power minus 10.
minus 10. My dear, unit. What is the unit for the capacitance? Farad. What is the unit for the length? Meter. Clear? Understand?
Yes. Yes.
That's it. So chapter, the question number 3 will be over. Clear, my dear?
Yes,
Understand?
Doctor.
Okay. What's the time now? I think the time right now is exactly 3:47. Still we have 10 minutes. Am I right? Okay. Better we can finish one question. Better we can finish one question. So what is our question? First question. Still we are not finished. Am I right? So I can copy this. Okay, read the question. Read the question very carefully. What is given in the question? You have 3 capacitor. Capacitor 1, capacitor 2, and capacitor 3. Am I right? Am I right or not?
Yes.
Okay, now you can see my capacitor 1 and capacitor 2 are exactly in the series form. Am I right? Am I right or not?
Yes.
But your capacitor 3 is different. It is not exactly series because I told you already one positive should connected with a negative, one negative should be connected with the positive. But according to the picture, if you just take this is positive, this is negative, this is positive, this is negative, this is positive, this is negative, your C3 will not come under this. Only your C1 and C2 are exactly in series. Am I right?
Yes.
Am I right or not? So we have the rule for series. What is the rule for series, my dear? What is the rule for series? Just before we've studied, what is the rule for series?
1 over C.
1 over C equivalent, which is equal to 1 over C1 plus 1 over C2. We studied this rule. Am I right? So I am going to apply this rule for the series. So what you will get? 1 over C equivalent, because in the question they clearly mention only you have to find the equivalent capacitance. That means they are not asking for 1 over C equivalent. They just need the information about C equivalent. Clear? So what I am going to do? First, I am going to apply the rule. After I find the 1 over C equivalent, I am going to convert this 1 over C equivalent to C equivalent. Okay? Understand? So 1 over C equivalent is which is equal to 1 over C1 plus 1 over C2. Am I right? So if you simplify this, if you take the LCM, this becomes C1 multiplied by C2, and the top, this becomes C2, this becomes C1. Am I right? Am I right or not?
Yes, Doctor.
Okay, now this is the value for 1 over C equivalent. This is the value for 1 over C equivalent. But they need the information about the equivalent. So what I have to do? Take the reciprocal of this. Therefore, my C equivalent, which is equal to C1, C2 divided by C2 plus C1.
plus C1.
Am I right?
Yes, you are.
Now we find the answer for this. Am I right? Am I right or not?
Yeah.
So what I am going to do, I am going to redraw this diagram again. So I just club these two as one. So this is my equivalent capacitors of C1 and 2. And then again we have one more capacitor which is nothing but C3. So now you can see this is my C equivalent of 1 and 2. But this is my C3. Am I right? Am I right or not?
Yes, doctor.
Now you can see these two are exactly in the parallel form. Am I right? Am I right or not?
Yes.
What is the rule for the parallel? So according to this picture, my C equivalent 1 and 2 and C3 are in parallel. Am I right? Am I right?
Yes.
So what is the rule for parallel? What is the rule for parallel? C equivalent, which is equal to C equivalent of 1, 2 plus C3. Am I right? Am I right?
Yes, doctor.
So take this C equivalent and substitute here. If you substitute here, what will happen, my dear? My C equivalent, which is equal to C1, C2 over C2 plus C1 plus C3. Am I right? Am I right?
Yes.
Okay, now you can see the value of C1, C2, C3 is given. What is the value? My C1 is 10 microfarad, my C2 is 8, my C3 is 4. So now you directly substitute the value, get the answer. So I need the answer now. So you have to work out now. Substitute the value here. My C1 value is 10 microfarad. So 10 multiplied by 10 to the power of minus 6 multiplied by my C2 value is 8 microfarad, 10 to the power of minus 6 divided by C2 value is 8 microfarad, 10 to the power of minus 6 plus my C1 value is 10 microfarad minus 6 and then plus my C3 value is 4 microfarad, 4 multiplied by 10 to the power of minus 6. Clear? Could you please tell me the answer? That will be your final answer. Tell me the answer.
8.44
8.44
multiplied by 10 power minus 6.
10 power minus 6. What's the unit for the capacitance? Farad. That's it. So my dear, listen carefully. Right now the time is 2:43, but we have one more question, and that question is a little bit lengthy. You can see the question. How many sub questions are there? 9 sub questions are there. This question, inshallah, I will discuss by next week. Okay.
Okay.
So far 5
Okay.
problems. You can see here, my dear. We finish this one. We finished 4th question. We finished 10, 12 and 21. Only the 6th question is left. So I will just finish this question. I will complete this chapter by next week. Clear?
Clear,
Doctor. Thank you.
Yes.
Okay, my dear. Have a nice day. Please prepare well for your quiz too. Understand?
Understand. Thank you,
Okay,
Doctor.
so inshallah, brother, prepare well. If you have any doubts, please feel free to communicate through WhatsApp group. Okay?
Okay, Doctor.
Okay, brother. Assalamu alaikum.
Walaikum salam. See you, Doctor.
See you, brother.